Let us now look at the concept of algorithms. By definition, an algorithm is a sequence of activities to be processed for getting desired output from given input. So there's some key words that we should remember. Well, firstly, sequence means one after the other. It's a sequence of activities. There's processing that takes place. We have input and we have output. And put them all together, a sequence of activities to be processed for getting desired output from given input. That is actually what an algorithm is all about. So why do we make use of algorithms? Well, before we start writing our programming code on computer, we want to write algorithms. And maybe the first point to make is that an algorithm can be written on paper. We don't need a computer to write our algorithm. By writing it on paper, it's helping us to organize our thoughts. We are trying to solve a particular problem. So to solve the problem, we need to organize our thoughts so that we can determine the sequence. Remember, it's a sequence of steps. So we understand the sequence of steps that are required in solving our problem. As I indicated, it's not dependent on any specific programming language when we're writing an algorithm. And we are not distracted by computer programming code or errors that you get. When you work in a computer programming language, you could possibly leave out something as little as a semicolon, and you will then get an error. A programming language is very particular about how you go about writing your activities or your steps. So by writing an algorithm, it's not that particular in terms of how you go about writing the steps. The key to take note of in an algorithm is you are organizing your thoughts and you are finding a way in how you would go about to solve the problem. So that is the main idea in why we write algorithms. In writing the algorithms, we should take note of three things, IPO. The first is input. Then we need to take note of process, so some processing takes place. And finally, we need to take note of output. So that is called IPO, our input, our process, and our output. Now this is critical when you are given any problem to solve. We need to identify these three parts within the problem that we have to solve. Input, these are the values that the algorithm requires to solve the problem. So you have to give the algorithm the values, your input values, in order for you to perform some processing and to get output. So that's the first step, getting the input. Then second is the execution of these steps. That is your process. So we have these steps that have to be performed. Possibly some calculations need to be executed. And processing is performed by executing those statements. And after those statements have been executed, we then get output. The output is where we get the desired answer that we want, and that answer is then displayed to the user. So we can think of an algorithm or an IPO in this way. First, we need our input. Then this is processed. And finally, we get the output. The input is typed by a user. So the user will type in some input. The processing is done by the computer. These are the steps that we need to give to the computer in a computer program that's processed. And finally, after the processing takes place, we then want to display the output. So we display the output so that the user ultimately can see what the answer is for the input that we had given to the program. As much as I'm using the word program, ultimately we want a program, but in this instance, we are applying it to an algorithm. The same concepts that we use in the algorithm in terms of the input, process, and output, those concepts will be also used when we are writing our program. So let's look at an example. In this example, we need to write an algorithm. And this is our question. So the question tells us, input the cost of one item. So immediately I can see what my input is. It's the cost of an item. You may go to some store and we purchase an item. So that is what we're going to input. Then we are told, add 5 Rand to the cost. So that's the input cost. Whatever value was input, we now need to add 5 Rand to that cost. And obviously when we add 5 Rand, we're going to get a new amount that possibly you need to pay. So the output is going to be the input amount plus the 5 Rand, giving you an output, which is the new amount. How would we go about writing this into an algorithm? So step 1. Step 1 is to perform the input. So input the cost. After you've got the cost of the item, we need to store it in a placeholder or variable. So input the cost and store that in a variable. So that's the first step. I've got my input. The second step, I'm taking the cost that I've input and I'm adding 5 to that cost. That is now my process. I get a new answer, and that answer is now stored in another variable, and that variable is called new cost. So it's a second placeholder that I have. And finally, in the third step, I am displaying, I say print, which means I'm outputting or I display the new cost that I calculated in step 2. So that is your output. And step 2 would have been your process. So that's your input, process, and output. So let's look at this table where we'll take some values and test to see how this algorithm would work. So in step 1, input the cost of an item. So let's assume the cost of the item is 50. So that is the cost of the item, 50 Rand. So in step 2, we are saying new cost is the cost. So here, let's put down cost equals 50. So in step 2, cost, which is 50 plus 5, that's my process, that's 55, and that's going to be stored in new cost. So now, new cost is equal to 50 plus 5, giving me 55. That's my process, step 2. Step 3, print new cost. So there's new cost. If I need to print it, it's now going to output, and we're going to get 55. So that could be one set of values that we are using to test our algorithm against. Let's now take another set of values to test the algorithm against. This time, let's go to step 1, input a cost, and let's say this time the cost is equal to 1,000 maybe. So we're taking a much larger value. So cost equals 1,000. In step 1, input the cost, 1,000. In step 2, cost plus 5. So 1,000, that's my cost. There it is. 1,000 plus 5 gives me 1,005. And that is stored in new cost. So we have new cost equals 1,000 plus 5, which is 1,005. And print new cost. So new cost is now 1,005. So that's the values you're going to get for your algorithm if your input is 1,000. You'll notice that in number 1, the first example, we had a different set of values, but it was applied to step 1, step 2, and step 3 of the algorithm in the same way that the example 2 was applied. It's just that the values changed. Let's take another third example. In this case, let's assume we buy something for a cost of, let's say maybe 5 Rand. So the cost is 5 Rand, that's step 1. Input the cost of an item, it's 5 Rand, that's the cost. Step 2, cost plus 5. What's the cost? 5. 5 plus 5. So the new cost is my cost, which is 5, plus 5, which is the value that I am adding. And that is calculation is going to be 5 plus 5, 10. And then in step 3, print new cost, it's going to display a value of 10. So you can see that we've written an algorithm, and in this table, we are testing the algorithm for 3 different sets of values. Where did I get these values from? I made them up. I'm taking different sets of values. So if my cost is 50, my input, my output is 55. It's 5 Rand more. If my cost is 1,000, my output is 1,005, 5 Rand more. My cost is 5, my input is 5, my output is 10, 5 Rand more than the input. And that is what the algorithm wanted us to do, input a cost and to add 5 to it and then output the new cost. So by using this table, we are now able to test our algorithm to determine the validity and to know whether it works or not. Let's look at another example. So in this example, we are told, there we are, I know what my input is. I need to input 2 numbers. So here I need 2 numbers. I then need to find the sum. So I've got 2 numbers, find the sum of the 2 numbers, and my output is the answer, which is the sum of the 2 numbers. So I need to get 2 numbers, find the sum of the 2 numbers, and output the sum, which is the answer. How would I go about writing the algorithm? Step 1, well, I need 2 numbers, so let's get the first number. And that number, I'm storing it in a variable called num1. Step 2, I'm inputting a second number, which I'm now storing in a variable called num2. Because I need 2 numbers, I decided to call my variables num1 and num2 because that was more meaningful. So that's my input. That's now done, that's complete. Let's look at, that was the input. Let's now look at the process. We need to find the sum. Well, to find the sum, you need to just add up the 2 numbers. But where are these 2 numbers? These 2 numbers are stored in 2 placeholders. The one placeholder is called num1, and the other placeholder is called num2. So whatever numbers are in here, we need to sum them up. So there it is. There's an error here. This should have been num1 So it's num1 plus num2. I add them up, I get an answer, and that goes and it is stored in a third placeholder called sum. So that is now my process. And finally, step 4, I'm saying print. Print it, this is my output. So what am I outputting? I'm outputting sum. That's the sum I calculated in step 3. And I'm also printing a message. In doing so, we're making our program user-friendly. So the output is going to tell the user that the sum is, and you'll notice when I'm using a message, I put that in quotes. So in my algorithm, I know when I use quotes in a print, that is a message. And I separate it with a comma, so my message and my variable are separated. There's no confusion. And then I have my variable sum. So this is how you'd go about writing your algorithm, but I'm not sure if the algorithm is correct. So let's use this table and test the validity of this algorithm. So step 1, input the first number. Well, let's say my first number, num1, is equal to 5. So input first number 5, that is stored in num1. Step 2, input second number. Let's say that is 10, and that is now stored in the variable num2. This is my first example that I'm doing. So first number stored in num1, second number stored in num2. Step 3, take num1, add it, plus means add to num2, and get an answer, and store that answer in sum. So take num1, which is 5, add it to num2, 5 plus 10 is 15, and store that in sum. So in my process, sum is going to be 10 plus 5. Actually, let's write it as 5 plus 10, which is going to give me an answer of 15. Then in step 4, we're going to print a message, and the message is going to say the sum is, and we want to print what is in the placeholder sum. And if we look at sum, we got the value 15. So it's going to say the sum is 15. And if you look at your input, 5 and 10, if we add them up, we're getting a value of 15. So I'm happy with that set of input values. Let's take a second example. We want to test different cases to see that it works for all the different cases. In step 1, input a number, num1. Let's take the number 1. In step 2, input a second number. Let's say num2 equals 1,000. So I've taken a large number, 1,000, and a small number, 1. Step 3, num1 plus num2, 1,000 plus 1, and that is stored in sum. So sum is equal to 1,000 plus 1, and that is going to give me 1,001. Step 4, print your message. The sum is, and print sum, which is 1,001. Finally, let's take another example just to be on the safe side to ensure that this works, because the second example was also correct. When you add 1,001, you get 1,001. So here, for example, number 3, input the first number. Let's say num1 equals 500. Step 2, input a second number. Let's say num2 equals 100. Step 3, num1 plus num2, 500 plus 1. That is stored in sum. So sum is equal to 500 plus 100, giving me 600. So sum has the value 600. Step 4, my message, the sum is, and We print sum. The value of sum is 600. And if you look at it, let's go back to the question, input two numbers, find the sum and output the answers. So if we look at our first set of input, 10, 5, sum is 15, and my output is the sum is 15. So that's correct. The second set of input, 1 and 1,000, add them up gives me 1,001, and the sum is 1,001. Correct. The last set of input, 500, 100 gives me 600. The sum is 600. So that is correct. I'm now confident that this algorithm that I've written will now work. I hope this video has helped you to get a better understanding on the concept of variables, understanding what are valid variables and what are not valid variables, and then taking that concept of variables and applying it in algorithms where you store values, and then writing your sequence of steps in your algorithm, and then using an IPO, an input process and output table, testing it for different sets of values to ensure that you are answering the question correctly. I hope this video helps you.